Hi everyone, today I want to share something about our health that goes beyond genetics. We used to think of DNA as a fixed blueprint. If our family had diabetes, we were likely to get it too. But now, scientists are discovering that it's not just DNA that affects our health. There's something called epigenetics. It controls how genes work by turning them on or off without changing the actual DNA. So what influences epigenetics? Our lifestyle. That means things like what we eat, how much stress we have, and how active we are can actually change how our genes behave. This is super important, especially for diseases like type 2 diabetes. Even if you're born with a risk, epigenetics shows that you might still be able to avoid it. We will demonstrate how epigenetics and diabetes are connected and how the science could change the way we think about health and prevention through this explanation and the remote extra actions.
Epigenetic dysregulation can be a key mechanism of T2D, which means type 2 diabetes. According to the PMC article, environmental variations, including alterations in lifestyle and nutrition, can cause epigenetic changes that may impact glucose homeostasis and the function of different organs, which can contribute to T2D. Now let's see a case of a patient. This patient has a famine during childhood, and the famine ended when he grew up. However, his epigenetic is already modified into a condition that adapts to low food intake. So he is likely to get diabetes even if he eats regular food.
Food. I need food. I'm so hungry. I don't want to die. Look, there's grass. Oh, grass. Great. I'm saved. Wow. Finally, I get some nice food. It tastes so nice. But why do I still feel hungry?
So how can we treat type 2 diabetes? The answer also lies in epigenetic. According to the American Diabetes Association website, studies have shown that physical activity can reduce DNA methylation in genes involved in glucose metabolism and insulin signaling, improving the body's ability to manage blood sugar. Therefore, physical exercise and a healthy diet can reverse some harmful epigenetic modification and can be a possible solution. Now let's see a successful rehabilitation case.
Damn it. Have I really been defeated just like that? I'm not convinced. Wait, what is that? It's coming. I feel powerful over. I want to dance.
Now that we have explored how epigenetics affect diabetes, we've heard how things like diet, physical activity, and even childhood experiences can influence gene expression. In other words, we're not stuck with what we were born with. But what's powerful is that these changes aren't permanent. Healthy habits like staying active, eating well, and managing stress can help switch those harmful gene signal offs. Remember the example of how exercise and a healthy routine can turn off harmful gene activity? That means we can actually lower our risk. Another human impact is that doctors can also use epigenetic markers to identify risk sooner and help people make lifestyle changes that really work. In conclusion, understanding epigenetics gives us the power to take control of our health, not just for ours, but for the next generation. It's more than science, it's a guide to better living.